Hi, my name is Andreas Olofsson, and I want to talk to you today about open source chip design. My background is as a chip designer for the last almost 20 years, since 1996, first in big companies and since 2008 in my own company. So even in this room, there are probably 1,000 different integrated circuits, in a community open source. I would bet big money that there's not a single one here that has an open source chip on their body. And am I going to lose that one? And the question is why, right? Why are there no open source chips? And it's more of an economical question than a philosophical question. Why haven't we made it happen? Today we define open source hardware at the electronics portion as kind of the Gerbers and above, not the chip below. We've said that maybe that's too expensive, we'll leave that to the big companies. It's okay to have a board with closed source chips because there are no open source chips. So the chip you see here is something I designed in 2011. It's a 64 core microprocessor as a very small company. It's not open source, but it was done at about 1/100th of the cost of something like the big companies do. And the question is, can we make it free? And what does that mean? But before I start talking about open source chip design, I want to talk about a baby step we did in 2012, where we launched our first open source platform, which was at the hardware level, completely open source, open docs, open Gerbers, open drivers, open software, everything, GPL licensed. And what we found out was, up until that point, we'd worked very hard in designing chips, but as Andy Grove of Intel would say, only the paranoid survive. So we only released our documents under NDA, and the company was dying. And by opening up, we actually saved the company. And at the end, we raised almost $1 million in Kickstarter. We had severe challenges, like I think the speaker, Nancy, said in the morning, many of those similar problems. The company almost went out of business, but it didn't. We persisted and survived, and certainly would have gone out of business if we wouldn't have done this project. So all in all, it was all good. And in terms of openness, so it was a huge success. We survived because of it and increased many things like sales, for example, by 40x before and after. So now, why can't the same thing happen in chip design? So those of you who don't know chip design, it's very opaque. The chip industry is one of the most opaque industries around. But it's not that complicated. Students design chips all the time at a smaller scales, PhD students at universities. Small companies tend to not design chips because of the cost. But basically, you start with an architecture specification. You'll take that architecture specification and you'll create some design at the microarchitecture level. That could be done with a schematic. So you're putting down symbols. Most of digital logic, at least, is done with Boolean algebra. So, ands and OR gates and things like that, storage. And so you express this in some way. It used to be done with a schematic. Today it's done with higher level languages, although quite arcane, things like Verilog, VHDL. And that language you feed into a compiler, a silicon compiler, which first translates that into some kind of netlist representation. And then you have a secondary translation step that translates that into actual polygons that get printed on the chip at the factory. And of course, once you have the silicon, you have to package it up. And then once you have a packaged chip, you can put it down the board and voila, you have something you can use. And some of the numbers that you see there on the left are some of the ridiculous costs of designing chips. Could you imagine telling a software designer that every bug you have costs you a year and $1 million? There wouldn't be very many software companies out there, at least not very many profitable ones. And so hardware design and chip design is very, very difficult. And to give you some more ideas of the costs involved today and the hurdles for making it open source, engineering, things are complex. You need a lot of engineers. Engineers are expensive and take time. Again, a year-long process. It's going to cost you a lot of money. That's where most of the money goes to. So if we can make it simpler, we can do it better. And by sharing more information, we can make those engineers much more efficient. IP licensing. Today, all the big companies, the reason they can actually produce chips at a reasonable cost is they license a lot of the IP that goes into it. which means that there are companies out there building proprietary IP, companies like ARM, who charges millions of dollars for licensing costs, and which means also makes it out of scope for a lot of small companies and projects. The tools, the silicon compilers they use are also costing millions of dollars. The tape outs themselves, when you actually ship the mask set, today is $5 million at 14 nanometer. And you go down that line. So we're talking about anywhere from $1 million at the absolute minimum up to $1 billion to develop a silicon platform. And that's why we draw the line at the chip, because clearly for the most people, the idea of having an open source computer that includes the chip is just a philosophical question. It's not, economically not practical. But what if we could make chip design free? And free as in freedom, and maybe free as in beer. And what would that mean? So what's happened in the kind of Moore's Law death march over the last 50 years, where all the companies are driving towards zero, right? The per transistor cost every year got cheaper. It's driven a lot of companies out of business. There are a few very, very big ones left. And I mean, to be honest with you, they're commercial companies. They only care about money. And because they're $5 to $50 billion companies, they only care about very big money, which means that if you come in with maybe a very important project for whatever reason, whether it's medical or social or something, you will not get the attention. So the only way you can design that project is by utilizing a commercial product that's gone into high volume opportunity, like a smartphone, and using that. And of course, unfortunately, a lot of those smartphone chips are also opaque. They don't even have data sheets. But the key area here is, what do you do between the 1 and 100,000 unit interesting idea or system that maybe you could build with a chip? You could use a chip there. And it doesn't really help you to put together weird parts that maybe have all kinds of junks that you don't need, where you could just design one chip that could, I mean, again, sky's the limit in terms of imagination here. But the areas are really not the consumer electronics, but the really interesting stuff, the health, the robotics, science, that really can't spin their own chips. And this is, I mean, talk about the kind of the grand challenge of open source design. You're going to displace $100 billion worth of industry to make this happen. The IP industry is a $5 billion industry. There is some open source code, but mostly goes into devices called FPGAs. Very few people, if any, use open source design to put into real chips. The EDA industry, the ones that make the silicon compiler, the sad part is in the 1980s, mostly in Silicon Valley, when they started working on logic synthesis and place and route, those universities actually had open source tools. And then they handed over the open source tools to the contractors, right? The EDA companies and startups that spun out of those universities. And it all went proprietary, and it's very much proprietary today. And those companies spent billions of dollars to make incredible tools that work amazingly. I use those tools every day. But a seat of those tools can cost you $1 million. So certainly not free. Similar issues are in the packaging and the manufacturing. So this is not something that one or two people can solve. But it's a solvable problem. It's been solved in industry. It's been solved in silos. I do believe it's a solvable problem. So in conclusion, as a chip guy, I'm very proud of our industry. We make a lot of things happen, especially with Moore's Law. The exponential growth in semiconductor over 50 years is unprecedented in history. Maybe we'll never see it again, although I doubt that because I'm an optimist. But it is incredible. So I think we have a responsibility to extend Moore's Law for another 50 years. And the way it is today, it's going to end by 2020. And so what do we do to extend Moore's Law by another 50 years? I believe that open source is a big part of that to make it happen. Thank you.